And so what we have here is I am showing you the another equation here. So I hope can you see that?
Not yet, sir.
No, sir.
But I share is it not visible? One minute. So can you see now?
Yes, sir.
So
Yes,
this
sir.
is actually you have another column in the category of simultaneous algebraic equation there. So here you have aniline is being removed from water while solvent extraction using pure toluene. Uh, the unit is a 10-stage countercurrent tower shown in following figure, so that you will see later. The equilibrium relationship valid for every stage is given by yi upon xi equal to 7.5, where yi has units kgs of aniline in toluene, extract phase per kg of toluene, and xi has units of aniline in water, raffinate phase per kg of water. The subscript I denotes the stage number, and by convention yi and xi represents the leaving streams for ith stage. The material balance around each stage, assuming dilute solutions, results in following equations. So these are your material balance equations here. So you can also write them, but you can see them that this will come. I will show you the figure, then you will have to cross check whether you are getting these equations or not. So stage 1 to 5. So let's see what stage 1 to 5 is. So So this is what you have here. Here you have water is entering from top, and this is what you are getting here. Something R, the recycled part or something. So you have a R, you are feeding a 30 kg first. So this is your conditions where you are feeding. So here you are feeding water. In the bottom, you are feeding pure toluene. So pure toluene you are means pumping from butter. And what toluene is doing actually? Toluene is actually extracting your aniline from water phase. So you have water here where it have its feed composition 0.05. Okay, so you are feeding that, and here you are just feeding a R. What is R here? R is actually your raffinate phase here, so you are just continuously feeding here. That is plate number 5. So first part is that you have to write a material balance equation for this particular column. So I hope you might have seen a extracted column in your mass transfer or not.
Sir, shouldn't R be reflux?
It is not a distillation column. Re,
Sir, but
reflux
from
distillation
the
column
top
में
we are
होता है.
getting. Sir, but from the top we are getting T plus R. So that R is coming below.
No, whatever you have to pump, that should go to up actually, no? Depend what material you have.
Okay, sir. Okay, sir. Got it.
Okay.
Yes, sir. Got
Okay,
it.
you are feeding toluene, you are feeding this R and toluene
Yes,
are
sir.
going to the top only. And whatever water you are feeding, that's you are going down here in that water phase. So this is your 10th stage. So that's clearly mentioned here, R10, X10 here. So this is your 10th plate. This one is your starting plate here. So plate 1, from where you are entering your feed.
So can you please zoom out a bit so that we can see the whole column at once?
Yeah, so I am doing that only. Now it's going to 2, but I want to show you single page. 1 minute. How to go to this full screen? Is there any way? Yeah. But I want only one page at a time. I hope can you see that? But I don't want this actually. Single page.
So we can
Ah,
see.
this is fine now, right? So this is what your extraction column is. So here you are having some material here which contained your aniline here. And now you are just passing here, and then you are. This is your material here which is being extracted with your toluene here. So you are just putting a toluene as a bottom material from here, and then you are passing it to the upward, and it will extract some amount of component from here, from this feed, and something whatever is coming here for the raffinate part also would be you are pumping at plate fifth plate, right? That's what they have the mention there after fifth plate. So if you will write a mass balance, let's say for this first plate here, so just write what is coming to this and what is going out from here. So this component is going from coming in here, first one. So this is coming with a feed composition XF here, and now this is coming. So next is for X. If, if it is 1 here, so or you can make it a 0 or 1, that is choice is yours. So if this plate number 1, so whatever thing would leave to it would become the X1 actually, right? So that would be the composition leaving to this. So because once they have a particular plate, so they will be in equilibrium actually. So equilibrium, one thing would go that yi will go to upside. So whatever leave to the upside part, we consider it a yi. Whatever is going down is being treated as xi actually, leaving the thing. So practically the nomenclature is that it's being treated to a in a plate way. So let's say it is plate number 1 here. So whatever is coming here, let's say x0, whatever is leaving to that is x1 because it's coming from 1. So coming from 1, we can give the nomenclature here x1. Same thing from here. So this part, it something is going from here. So this going up from here, so it's from y1. And whatever coming to this, it is coming from plate number 2. So you have there for y2. So y2 is coming in, y2 is leaving the thing. So whatever the leaving the that particular plate, give that particular the subscript compare considering that plate number. So if it is 1, so whatever would leave this plate would be given as 1. Whatever is coming, we have to see from where it is coming. So if this is coming from here, this part here, so this part is coming, so this would be maybe your x 1 minus 0, so 1 less of that, so it will become x0. Is leaving from here would become x1 here, that way. So that way, if you will write your equations, so if you write that equations, you will end up with this one. So stage 1 to 5, you are W plus Xi, which is coming to that. What is coming to that to this plate from bottom side? Your toluene you are feeding something R is also being fed to this the particular column. So two things from bottom are coming, R and T. So you can see from here, this R would also come up and T is also coming from bottom. So these two are coming actually. Okay. Hello.
Yes, sir. Yes,
So
sir.
these two are coming to you, that your R and so your R and T. So these are coming to this. What compositions so that you have to write here. So same thing we have the wrote here that xi plus T plus R yi. These are coming to this. What the
Sir,
leaving that? Yes.
sir, one question, sir. So,
Yeah.
sir, XI is coming down, no, sir. Like the water is coming down, and the toluene and R is going up, na, sir. So the sign shouldn't be it be minus because both in opposite direction.
No. How minus? We are balancing mass coming in and going out. So whatever is coming, that should be added. That should be balanced with whatever is going out.
Okay, sir.
It's just a mass balance. Sign ka koi, this is not a vector algebra something. It is just a mass balance. You are
Okay, sir.
doing mass balance, the total thing coming to this should be added to one side, should be balanced what is going out.
Yes, sir.
Okay?
Yes, sir.
So W was coming in, T plus bar also coming in, just multiply by corresponding their actually compositions. So if you are just multiplying the compositions here, so you multiply xi here, yi. So these are their composition, whatever coming in. Now you have to say the nomenclature there that what coming in, what thing have you given that? Have you given that name xi or xi minus 1? That is completely in your hand. It is not a straightforward rule for that. Okay, fine. Only thing you are multiplying its composition only. That's all. Mass flow rate multiplying by its composition. That will be the amount coming in. Whether you are giving xi minus 1, that is the your convenience. Is that fine?
Yes, sir.
Yes.
Huh. Now you balance that thing, whatever is going out. So going out is W xi minus 1. So you are just saying in that case, the going out you have considered xi minus 1 in terms of W, and whatever coming in you have considered x1. Okay, xi. Same thing from here, you will come to know that what is here. This is T y plus R. This is going out. So you are multiplying it yi plus 1. So what have you considered here? That whatever is coming here, you have just given a nomenclature I. Fine. Now, in case of downward side, whatever is going down, you are just considering I minus 1. And whatever is actually going to the upward side, you are just considering I plus 1. Okay?
Yes, sir.
Fine. So
Yes.
this is the condition till stage 5 actually. Okay. This is the condition till stage 5 because the stage 5 पे आप ये R insert कर रहे हैं. So from there onward balance is different. Now what will happen after that? Means after that here, this is your stage 5. So whatever R you are feeding here, that is going to upside. Now we have to write the balance from sixth place onward. So sixth place onward के साथ you don't have R there. At this particular plane, you don't have R. You have only what is coming here, this toluene. What is going out here, this W. What is coming from top is again W. Okay. And what will leave also from here? Because T is coming, so T will only leave, right? Hello?
Yes,
Yes,
sir.
sir.
So therefore, you wrote the balance for that here. Now you have wrote here that this WI this is from the seventh place onward. This is from the seventh plate WI this was thing what coming in. This was also TYI, which is actually your coming in again. Now these are the things which were your going out only. W xi minus 1 plus T yi plus 1. So you have balance again from this. Now this is the condition as प्लेट नंबर 6 जहां पे आप फीड को इन कर रहे हैं. जहां पे इन करेंगे वहां पे आपने कुछ इंसर्ट किया न्यू मटेरियल. दिस इज व्हाट यू हैव इंसर्टेड विद सम कंपोजिशन वाई एफ. तो यहाँ पे क्या होगा, जो आपका पुराना आ रहा है वो भी आ रहा है, प्लस यू हैव एडेड समथिंग मोर हियर आल्सो, राइट? हेलो.
Yes, sir.
So you have added that. For that also you have separate equation for that. यहाँ पे you got WXI that was coming in. TYI was already coming in from the bottom side. You have inserted something from outside, that is your R, which is उसका composition कितना था? Hello?
Yes, sir.
Hello, can you hear me?
Yes, sir.
Hello?
Yes,
Hello?
sir. Hello.
Hello?
So we can hear you, sir.
Yes, sir.
Not actually. 1 minute actually. Let me connect the head. Hello?
Yes,
Yes,
sir.
sir.
So at this plate, you have also inserted the something coming in here, that R plus F, which was the new material which you have the added. You already mean the adding the something was coming in. So you have added one more component from outside. This is the condition from where you are feeding the material in. Now that would have the separate. Once you have feed it in, your accept would be added to somewhere in the yi from that plate onwards. So you have to write your equation in three phases. One from the part from where you are means just from the top section. Then one you have bottom section. So just like in the distillation column, you are feeding a feed there. So equation for feed line at the feed plate is the different compared to what you have on top, what you have on bottom side.
Sir,
Okay? Yeah.
sir, can you explain how did we get RYF in output? Like that we are
No,
feeding,
no,
na sir, RYF. We are feeding it again
no,
in
no.
plate.
It's not that way actually. I will tell you what this is. So here, let's say this is your seventh plate, sixth plate here. This is from 1 to 5. This is your plate number 6 here. ठीक है?
Yes, sir.
यहाँ पे you are feeding a component which have this R. Let's see what this R is actually. W is water chlorate, that is 250 kg per hour. T is pure toluene, which you are feeding from bottom. Or the solvent, the recycled fluorate, which is coming from the somewhere, recycled solvent, which have some composition into that. Accept is given your weight fractions of the aniline in aqueous phase containing 0.05. So that जो आपके पास water chlorate आता है is containing some aniline. YF is weight fractions of the aniline in the recycling stream. Fine. Now let's see here. At this particular plate, 6 plate, your plate is something like that. Fine. You have a plate there. Now what is happening after that? What happened to this my video? I can't see what I'm talking. Can you see my video? It's off actually.
Yes, sir. It's freeze.
But
Yes,
yeah,
the video is visible, but it's frozen.
I don't know what happened. So what to do now? I think it's fine now.
Yes,
Yes,
sir.
sir, it's fine.
Yes, sir.
So what you have a plate. Now from here, as you know that something is coming from top side, that's fine. Something is going from means going down, that is also fine. Something is already coming in from the bottom, that is also fine. Now what happened that from here जो आपने feed किया वो कहाँ गया? Has it gone to the bottom?
No,
क्या ये
sir, to
बॉटम में गया? नहीं ना, ये यहाँ से यहाँ पे लोड हुआ और यहाँ के बाद ऊपर ही चलना चालू कर दिया. Yes or no?
Yes, sir.
Okay.
yes,
So whatever is fed there, वो यहाँ आके it went straight forward upside. It was not going downside. So इतना material आपने add किया, but it's going in upward side.
Okay, sir.
So that way, can you expand these equations actually, or can you try to write it, because it might be possible that I might have done wrong here, because it's not a 100% rule thing that I might have done everything correct. So you just think, you just write equation for let's say this is your plate one. एक आप column बनाइए, just make a column, just like this only. You write the equation because it might be possible that time I might be writing in R and J thing and IJ thing. I might have done that wrong also. So this is one way to cross check. So ये आपके पास, you have this column only where XF and YI are your aniline composition. Practically you are doing the aniline balance only. Fine. Okay. So can you write
Yes, sir.
equation? Let's say this you give plate number one. So you just write for plate number one. Same way you write plate number 2, 3, 4, 5, 6, 7, 8, 9, 10 equation. So can you write them that, so that we can cross check whatever I wrote in terms of I and J is correct or not?
yes, sir, we can try.
हाँ.
Yes, sir. Sir, can
Or
you?
before that, I can be the debate something here. Why this T plus R here in this side?
Sir, because we are adding R in stage 6, so
Okay.
it is considered that R is leaving stage 6. It is considered like that. That's why we are writing is T.
Yeah, it is practically that you are making the things homogeneous actually. So जहाँ पे वहाँ जो सारी चीजें आ रही हैं एक particular point पे, once they reach at that particular point, they will become in equilibrium.
Yes, sir.
Okay. So try to write, all of you try to write the equation for plate 1 first. Then you write plate 2, 3, 4, and 5, so that we can generalize in terms of I and J. We can write in terms of I and J, or we can write that separately from that, because it is not a generalized problem actually, but it can be the generalized actually, because you can change your location of feed. So if you can write in terms of I and J, so location of feed you can alter, you can change, so that you can get maximum extraction actually. So that is the different part. So first you write for first plate, then plate 2, then plate 3. लिखिए जरा क्या आता है. Or in the safer side, from program point of view, you just don't take anything at x0 or y0 because your program doesn't consider zero, no? So you just say that at least you should have a subscript 1 so that it would be easy to write a program because zero hoga for that also you have to again convert it to 1, and it's better to have one from beginning itself. As mass balance simple concept is just don't get confused with this. Just add whatever coming in need to be balanced with whatever going out. कहाँ से आ रहा है कैसे आ रहा है that's not the concern. Okay.
Okay. Okay, sir.
Yeah, just keep the simple mass balance that let's say we are collecting something from in some container. Whatever is coming, that should be added to one of the side. कहीं से आ रहा है कैसे भी आ रहा है that's okay. Whatever is coming and whatever is going that should be balanced by the another side. That's all. The simple only. So let's say you are taking plate 1. So coming in, let's say you are taking x1. Going out, you are considering, let's say, x2. And same thing for that also, for y also. So going out, if you are considering, let's say, from 1, so you have to give a जो है nomenclature here. So whatever leaving from 1, leaving stream के लिए आप 1 कहने वाले हो या incoming के लिए 1 कह रहे हो, that you have to decide. Because incoming is coming from some back stage, right? तो वो कहाँ से आ रहा है? स्टेज 2 से आ रहा है, करेक्ट और नॉट? हेलो, कैन यू हियर?
Yes, sir.
हाँ,
Yes,
so
sir.
whatever is coming to plate 1, let's say in terms of y side, so y side वाला जो आ रहा है वो that is coming from stage 2, so that is your y2 coming into plate 1 in terms of y. लीविंग कहाँ से कर रहा है? लीव करके वो कहाँ से आ रहा है? इट्स कमिंग फ्रॉम प्लेट 1, so that's y1, और that is for y के केस में हो गया 2 and 1. let's say for x, and x वाले के लिए इस leaving part you can consider is 1 because it's going for stage 2. So 2 से जो leave करेगा that would be 2, and what coming in को लिए आपके पास अब choice नहीं बच रहा है, वो फिर automatically 0 बन जा रहा है. Yes or no? क्योंकि 1 के बाद क्या स्टेज होगा आपके पास? आफ्टर स्टेज 1 व्हाट स्टेज वुड यू हैव?
Two, sir.
आफ्टर 1, 1 तो आपकी लास्ट स्टेज है, 1 आपका लास्ट स्टेज है टॉप वाला, उसके बाद तो कोई स्टेज जहाँ रहेगा नहीं ना,
Okay.
तो दैट उसको 2 देने का कोई पॉइंट नहीं बनता, क्योंकि 2 तो आपका नीचे है स्टेज 2, तो दैट्स व्हाट यू आर गिविंग, दैट इज x0, करेक्ट और नॉट?
Yes, sir.
ठीक है ना? सो 1 वाले का जो कंपोनेंट है वो जा रहा है 2 के लिए, तो जाने के लिए तो ठीक है, पैक्स 1 से आ रहा है वो, सो 1 से जो आ रहा है, तो प्रैक्टिकली आपका जो है नॉमेनक्लेचर ये है कि जो उस प्लेट को लीव कर रहा है दैट इज गिविंग दैट प्लेट नंबर, and whatever is coming from where it's coming you have to give that number also. So whatever is coming from that, so in terms of y it's coming from 2, in terms of x because of आपके पास टॉप के 1 के बाद आपके पास प्लेट नहीं है, so that's you can give the 0 there. Okay, 0 or x something. तो लिखिए आपका इक्वेशन
Sir,
स्टेज 1
Yes, sir.
स्टेज 1 का चेक कर लें, जो मैंने लिखा है, जो हम अभी बात कर रहे थे, इज इट फाइन और नॉट?
no, sir.
हाँ,
No, sir. I'm getting a different equation, sir. According to me, the flow rates should also be denoted like that. Now we are just denoting the fractions in the form of ij. We should also donate the flow rates according to that. For example, I am getting W
no,
minus 1.
flow, see the flow rate will not change. W is only thing. What is the W? So W will not change.
Sir, but when we are moving from one stage to another, we are extracting something from water. So if we are extracting something from water, then the flow rate of water is bound to decrease. It won't
How?
remain the same.
If you are talking about the steady state column, whatever you are feeding, and let's say you are just so having this W. Can you read the what this W is? Can you read this properly?
Yes, sir.
It is water flow rate. It is water. It's not water plus aniline. Can you see this?
Yes, sir.
So it's water flow rate. So water flow rate will not change. Water would be water.
And sir, if it was water plus aniline, then the
If water plus aniline, then you have to calculate the component which uh, i- is getting extracted and all this. You have to balance in that way. But it is water only. Water
okay,
जो
sir.
आ रहा है is going down only. Okay?
Okay, sir.
ठीक है, सेम थिंग टॉलुइन, टॉलुइन आप फीड कर रहे हैं, इट्स नॉट गोइंग आउट विद वाटर, वी आर जस्ट कंसीडरिंग दैट व्हाटएवर टॉलुइन वी आर फीडिंग इट विल जस्ट गो आउट ओनली.
Okay, sir.
ठीक है ना?
Okay, sir.
So it's just like that in chemical process calculations. You used to calculate the thing something on dry basis thing, right?
Yes, sir.
सुना है कभी तो ड्राई बेसिस थिंग. तो ये एक तरह का ड्राई बेसिस ही है. आप का वाटर इज द सॉलिड मटेरियल थिंग and that's you are considering as the dry basis. Out of that you have the loading inside that based on water flow rate you have 0.05% fraction of that. So is 0.250 को 0.05 से if you will multiply you will get the amount of the means the aniline. If you will add them up that would be your total flow rate. So in that case you have to consider all that particular parts. Equation 1 आया आपका? Can anyone tell what would be the equation 1 for plate 1?
Yes, sir.
Is it coming W plus X, W into X0 plus T plus R Y2 equal to T plus R Y1 plus W X1. Is it coming that much?
Yes, sir.
Yes, sir.
Okay.
Yes,
Same
sir.
way you can write for your till your 6 प्लेट. तो 6 प्लेट तक आपका इक्वेशन ये सेम रहेगा ये वाला समथिंग. आई और जे आप उसको फिर बाद में कन्वर्ट कर लेंगे कैसे करना है. सो ये वाला पार्ट है. अब यहाँ पे देखिए जो हम पहले एक्सप्लेन कर रहे थे अभी आई एम कंसीडरिंग माय मिस्टेक देयर एट दैट पर्टिकुलर टाइम. So from here, this part, if you will cross check with your equation and with this, so this right hand side, your part of in, ये in वाला part है. Right hand side जो part है ये in वाला है क्योंकि W x naught was coming in, T plus R Y2 is coming in also, right? ये आपका in वाला part है. ये आपका out वाला part है W in x1 T plus R Y1. Is that fine?
Yes, sir.
यही आएगा in terms of
Yes, sir.
ING.
Yes, sir.
Yes, sir.
Now come to the sixth place. So in all these three ये left hand side वाला part जो है ये आपका R है मतलब outside part है and ये this side part is inside part है. Right side वाला part. Left side वाला outside means the leaving stream है and right side was is the incoming stream. So let's say for the sixth place पे आपने feed किया. So उस पे in कितना आ रहा है WI आ रहा है. एक तो नीचे से TY आ रहा था एक आपने और ऐड कर दिया था. तो दिस इज द माय मिस्टेक एट दैट पर्टिकुलर टाइम. तो ये तीनों का तीनों कंपोनेंट ये इस पे आ रहा था. नाउ व्हाट इज लीविंग फ्रॉम हियर T plus R विद द कंपोजिशन ऑफ YI जो उसको लीव करके जा रहा है एट ith plate now is sixth plate. What is the leaving here W into XI X6 leave कर रहा है. So if you just put a I here 6 here, so this is W into X6 plus T plus R Y6 which will leave also. What is coming in W plus X5 here that was coming from the fifth plate. T plus Y I plus 1 this is coming from the seventh plate and now R plus F you have added from your side. Is that fine?
Yes, sir.
Yes,
So this
sir.
is your the sixth place. Now after the sixth place ये आपके पास R नहीं है बाकी सब कुछ है. Right? So from the sixth plate one whatever you have added you have the added here R. So just cut out the R there. You are not feeding XF also. So this in this only you just make this R equal to 0 and then this term would automatically will go away. Is that fine?
Yes, sir.
Yes, sir.
Now in that case once you will formulate here you are getting two things. One is getting X0. What is your X0 now? Your X0 is nothing but your XF, right? So you will replace your X0 by XF. Why have you already feed it there? Now from here you are getting something here, y11, right? जब आप 10th plate पे आएंगे, you are having there y11 coming in. Y the 11 practically here, whatever coming with toluene feed, right? That is the composition of this pure toluene. So जब pure toluene feed करेंगे तो y11 कितना होगा? Y is composition of, we are doing this balance completely for aniline. तो प्योर टॉलुइन में y11 कितना होगा?
Zero.
Right? So you have everything, right? You have W, you have your T, you have your R, and you have your what would be this y1 then? ये वाला y1 ये आपको known होगा unknown होगा?
Unknown.
Okay, कैलकुलेट कैसे करेंगे? ये आपके पास यहाँ से आएंगी कितनी इक्वेशंस आएंगी? यहाँ से 10 आ गई. You got 10 इक्वेशंस, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. All you have here xi भी है yi है. So xi and yi का relation you have from here. So you can convert either xi into yi or yi into xi. Choice is completely yours.
Yes, sir.
So you will get here 10. So you can convert this in terms of maybe let's say yi something if you want that. Then can we calculate composition on each plate? That's what we want to calculate here. The problem statement further is make a MATLAB program that consists a man body. Man body means just a man program and a subroutine for Gauss-Jordan. So here I want to calculate it by Gauss-Jordan, but you can solve it Gauss-Jordan, Gauss-Seidel. Okay, programming if you are made for one, it would be same for all. The coefficient of equations must be stored in matrix, that you will already do it once you will make a program. Output printout must contain coefficient matrix for problem solving values yi and xi for all the stages. So at all stages you have to calculate the yi and xi. Means you have to calculate the equilibrium composition leaving that particular plates. Solve same thing by the Gauss-Seidel, another printout of that, and just do the number of the iterations. So you can solve it by two methods and all this. So you have to, for you, the everything is given to you. Equilibrium, the relation is given to you. You have to just calculate at all stages equilibrium compositions. Okay. The another type problem could be there that you can change this problem. Also, let's say you have this, you have fixed up somehow your top composition. आपने ये somehow आपने top composition fix कर दिया. Rest of the things you know. You may be asked that calculate the number of the plates. So you can change your number of plates here, I. You can change your location of the feed, that what place should I insert my R so that I can get this desired value. Or let's say one person say, no, I will feed it plate number 6. Now you have only choice is just to increase or decrease the plate in top column only, right? Top part. Yes or no?
Yes, sir.
भाई आपके पास that is the variable, okay, that you can keep on changing till you get your desired concentration on the top. Or if you want to make two-way, let's say I can adjust both the things, not only with the plate, I will also adjust the location of feed, because as per my mass transfer, the knowledge, I can alter this composition by two ways, either by increasing more number of plates or by changing the location of the something which is I am the inserting the fresh material at the somewhere inside the column. Correct or not? So this is also the same type of problem. Here also you ended up with your simultaneous algebraic equations that can be solved also with the same program which we have made for previous one also. So I would say just previous one, please complete it. And if you are getting any problem in that, we will discuss here at least. Okay? ठीक है?
Okay, sir.
Yes, sir.
So we will end up the class here. Try to make this complete program. पहले आप has to write equations. In this case, you already have it. Try to complete that program because that is your say your backbone only. Just try to finish it by today. Time लगाइए कुछ हो जाए. नहीं होगा तो what can I give? I can also only help if you can learn it. If you will not there, I can provide you the my program. That is the only thing I can do. Okay.
Okay, sir.
Okay, sir.
Okay,
So
sir.
we will end up the class here. Try to do it, and I hope it will be done actually.
Okay, sir.
Okay then. Bye.
Okay, sir. Thank you, sir.
Yeah. Yeah.
Thank you, sir.
Thank
Thank
you.
you.